guys, welcome. We are going to be taking notes on rational exponents today, but first thing I'd like you to do is try this warm-up. So go ahead and pause the video and try this warm-up and see if you can get it, and then I'll show the answers in a sec. Alright, go ahead and check your answers for each one. Check your answers, and I put the work down for each one as well. And if you need more time to see this, go ahead and pause the video. Alright, so let's go ahead and dive in. Rational exponents. So a rational function means we're talking about fractions. So we're talking about exponents that are fractions here. So something like x to the n over m power. Now, how I like to remember to simplify is if I remembered a bow tie. And what bow tie stands for? It stands for bottom out, top in. So the bottom number is going to go out, and this is going to tell us the root. And the top number stays in, and this will be our exponent. So what does this look like? The bottom number goes out and tells us the root. So this is the mth root of x to the n. Now, order here doesn't matter, okay? So we could do the mth root first and then raise it to the nth power, or we could raise it to the nth power and then do the mth root. So another way we can kind of think about this is the mth root of x all raised to the nth power. And either method works. I personally like this method because you're taking the root first, so it makes the number smaller and then bigger. Here you make the number bigger and then smaller, so sometimes your numbers get really big. And I'll show you the difference between them here. So number 1. Let's look at 125 to the 2/3 power. 125 to the 2/3 power. So let's do it this way first, the way that I'm not the biggest fan of. So bottom out, so this becomes the cube root of 125 squared. Okay, so then we need to square 125. And I don't know that off the top of my head, so I'd have to use a calculator. So I would get the cube root of 15,625. Cube root of 15,625. And again, I don't know what the cube root of that number is off the top of my head, so I'd have to use a calculator to figure it out. And I would get 25. All right, so now let's try it the other way, where we do the root part first. So our setup is fairly similar too. The cube root of 125 squared. Except this time, I'm going to cube root it first. The cube root of 125, I know. That's 5. So this becomes 5 squared, which is 25. So notice we get the same answer. So it doesn't matter which method we're doing, but one made our numbers smaller first and then bigger. So this is the way I'm going to think about it first. I'm going to do the root first and then raise it to a power. All right, so what I'd like you guys to do is go ahead and try 32 to the 3/5 power. 32 to the 3/5 power. Go ahead and pause the video and try this one on your own. All right, so you should get 8 for this one. The 5th root of 32 is 2, and 2 to the 3rd power is 8. All right, let's keep going. So what happens if we have negative numbers? Negative 8 to the 2/3 power. Negative 8 to the 2/3 power. So let's bow tie this. So bottom out. So I have negative 8 squared. And we keep the negative inside the parenthesis because in case you're using a calculator, you're checking your answer with the calculator here. If you don't put parentheses around it, the calculator is going to give you a different answer because it does order of operations. So like if we were to square negative 8 without the parentheses, it would give us negative 64. However, negative 8 times negative 8 is positive 64. So make sure anytime especially when you're dealing with negatives, you're putting parentheses. All right. The cube root of negative 8 is negative 2. So this becomes negative 2 squared. And negative 2 squared is a positive 4. All right. So that's if the number is negative. You just treat it like a negative number. Now what happens if the exponent is negative? So if I have 4 to the negative 3/2 powers. Now, if you remember from middle school math / algebra 1, that negative exponents, what they do is they move things to the denominator. So the negative part of the exponent will move our function to the denominator. So we're just going to treat it like a normal bow tie problem until we get to the fact that we need to use the negative exponent. So the bottom goes on the outside. So the square root of 4 to the negative 3rd power. The square root of 4 is 2. So this becomes 2 to the negative 3rd power. And now I'm going to use the fact that this is a negative exponent, and it moves this function, or this number, to the denominator. So this is going to be 1 over 2 cubed. So we move it to the denominator, and now our exponent is positive. Well, 2 cubed is 8, so this becomes 1 over 8. All right, I'd like you to try this one on your own. So you're going to do negative 27 to the negative 1/3 power. Negative 27 to the negative 1/3 power. So go ahead and pause the video and try this problem out. All right, you should get negative 1/3 as your answer here. Negative 1/3 as your answer here. All right. So what else could we do if our exponents are fractions? All right, let's look at x to the 5/6 power, y to the negative 2/3, all raised to the 18th power. All right, now remember our exponent rules. Here, we're not adding or subtracting. In here, we're just raising it to a power. So when we raise it, if we're multiplying on the inside, we can distribute this exponent to each exponent. And when we raise a power to a power, we multiply. So this is going to be x to the 5/6 times 18 times y to the negative 2/3 times 18. So when we multiply fractions, this is 5 times over 6 times 18 over 1. And we could reduce first. Sorry, this is for this function. Multiply the tops and divide the bottoms. So this, I can reduce this by 6. So I would get 15. So this would be x to the 15th power. We do the same thing with the y's. 18 divided by 3 is 6, times the negative 2 is negative 12. So I've got 18 to the 15th, y to the negative 12. Remember, negative exponents are going to move our function or our term to the denominator. So we're going to move the y term to the denominator. The x stays on top. So I've got x to the 15th over y to the 12th. So I want you guys to try number 7. Let's do x to the 7/10, y to the negative 3/5, all raised to the negative 10th power. So go ahead and pause the video and try this problem out. All right, you should get y to the 6 over x to the 7th. So if you need to see it worked out, go ahead and pause the video real quick. All right, number 8. Let's do x to the 1/2, y to the 4/3, times x to the 1/5, y to the 1/4. All right, now here again, we're multiplying these two terms together. Now when we multiply variables, we add their exponents. So for example, if I had x to the 5th times x squared, this would be x to the 7th. So we're doing that same idea here. X to the 1/2 times x to the 1/5 means we're adding the exponents. X to the 1/2 plus 1/5. And the same thing with the y's. So I'd get y to the 4/3 plus 1/4. Now when we're adding fractions, we need common denominators. So if I look at the x, I've got a 2 and a 5 on the denominator. So I'm going to try and make these both 10. So I would multiply the 1/2 by 5 over 5 and the 1/5 by 2 over 2. So I'd get x to the 5/10 plus 2/10. And then I look at the y's. I need common denominators, and I've got a 3 and a 4, so I'm going to try and make them both 12. So I multiply the first one by 4 over 4, and the second one by 3 over 3. So I get y to the 16/12 plus 3/12. So 5/10 plus 2/10 is 7/10. And for the y, 6/12 plus 3/12 is 19/12. Can't reduce any of those fractions, so this is our answer. All right. Number 9. Let's do 9x to the 4th, y to the negative 6th, to the negative 3/2. 9x to the 4th, y to the negative 6, all raised to the negative 3/2. So, negative 3/2 as an exponent. We are going to distribute this as an exponent to each of my 3 terms, to my constant, or my coefficient in front, to my x, and to my y. So I would get 9 to the negative 3/2 power. x to the fourth times negative 3/2, y to the negative 6 times negative 3/2. All right, now I'm going to do the variable ones first because they're a little bit easier. We're just multiplying these together. So 4 times negative 3 is negative 12, divided by 2 is negative 6. Negative 6 times negative 3 is 18, divided by 2 is 9. Now, this 9 to the negative 3/2, to figure this out, we're going to bow tie this. This is like one of the first problems we did. So the bottom number goes out. So the square root of 9 to the negative third. Well, the square root of 9 is 2. So this becomes 2 to the negative third. Ooh, excuse me. That is incorrect. Square root of 9 is 3. This becomes 3 to the negative third. Negative exponents, move it on the denominator. So this is 1 over 3 to the third, which is 1 over 27. So I'm going to put all three of these together. 27 goes on the denominator. X to the negative 6, this has a negative exponent, so we put x to the 6 on the bottom. And y to the 9th is a positive exponent, so we put y to the 9th on top. And this would be our answer. Right, so that's it for the notes today. Thank you for following along and taking notes. I appreciate you.